I'll pick about five. The first point is basically that the carbon dioxide, this gas that you breathe out, is actually increasing in the atmosphere of the Earth. The second one is that all that CO2 that's been rising is all caused by fossil fuel products, essentially all this combustion. I mean, from your driving your car, cooking your food, so on and so forth. And then the third point is, key tenet that one should challenge. Actually, I meant to tell you that I am wanting to challenge these five tenets in this interview, is that this thing causes global warming, and then nothing else matter, like the sun, ocean, wave, and so on and so forth. It's only the carbon dioxide. So it's basically one single variable driving the whole complex climate system. So that's one of them. And by the way, another point that I miss when I say CO2 is only fossil fuel, and then one cannot challenge it. That's another point. This is one of those problematic issues when you say that all the science is 100% settled and there's no room for asking simple questions. Okay? And then finally, one of the tenets is that that you can use this thing called the computer climate model simply because our human brains are not good enough to memorize all of this, ebbs and flow of the climate system, like the wind blowing left, blowing right, and so on and so forth, or the ice growing and melting, that sort of thing throughout the season. That you can use this computer climate model not to understand what causes the climate to change, but to try to tell you about what the climate will do in the next 10, 50, and 100 years, or even 1,000 years. Sometimes it's so ridiculous that these people are talking about 100,000 years ahead of us, using their so-called computer climate model. And the news is that all of these basic tenets and claims that is run by this, what we call CO2 dangerous anthropogenic global warming idea, is not a hypothesis simply because this has not been formulated as a scientific proposition. It's all just an assertion that cannot be challenged. So this is why, as a scientist, we have a really important duty to try to explain not only to ourselves, not only to the politician, not only to my wife and family and all that, but to explain especially for those who wanted to know the answer, including school children, including any lay public. I mean, Al Gore, please, I'd like to explain something to him if he wants to listen, and anybody who wants to know the truth. So it's nothing but the truth that we are going after. That's where the problem of this sort of I would say very strong assertion, in fact almost religious assertion, to say that no one can challenge this idea that rising carbon dioxide is going to warm the globe, and in a very strange way, by the way. It's strange in such a way that this warming is only going to cause something negative, meaning that all the problems, everything that you can link to a problem, like even more people staying in jail will be related to global warming. If you read stuff like Mark Moreno's book and compilation of all the bad stuff that can be caused by anthropogenic global warming. So this level of discussion has becoming so ridiculous that I think we really need to take a really big step back. So as a scientist, we constantly take a step back because every day we reevaluate what we think that is true. And then we try to check. And what do you mean by checking? Checking here now, according to the layman language, is that we require actual measurement, actual experimental evidence and data, they call it. In Australian, they call it data. I mean, those data people, they all love to have data because we need to have data to try to make a point. If you say the globe is warming, by all means, we must have the global temperature to show that the temperature is rising. By the way, it's not warming, so it's not actually showing that. So this is a problem now with all this sort of a hand-waving issue and all this, what you call top-down sort of approach from basically all these alarmists, this DAGW people, the dangerous anthropogenic global warming proponents, including Al Gore and all these Nobel Prizes winners, what have you. The only problem with all of that is that science do not respect who you are and what you are and all that. It's just what the facts are. Please give us the facts, and therefore we can proceed and try to understand what is going on. And all I've been trying to do all these years is just to try to understand what is going on. how do you try to go about try to understand this world, flow of air and ocean currents and even growth of trees and how the changes in the landscape and so on and so forth, in the sense that we are trying to get at the understanding of what is weather, what is climate, right? So the proponent from this, what you call the United Nations Intergovernmental Panel on Climate Change, has been insisting for a very long time, by the way, since 1990. So that's close to 28 years. And they've been insisting that we don't have to understand what causes the climate to change today. And that is a very strange proposition, because they keep saying that, we don't have to worry about what the climate is doing today. All we need to be worried about, because all we are after is actually a policy prescription. Therefore, we can use so-called computer climate model to the best of our ability. They always would say something like that, but it doesn't help science. It doesn't help facts. It doesn't help to explain. It's to use the computer climate model to try to see what the rising carbon dioxide would do to the climate system. By the way, all of that sounded very reasonable. The only problem is that these folks are not interested in what the outcome are. They are not inquisitive at all. All they are interested is using this, what you call, by the way, I wouldn't even compare climate model to your knife. Your knife is fairly useful. It can chop tree, cut fruits, it can do vegetable salads, it can do so many things. It can chop meat, do meat, all this useful aspect of it. And then if you ask yourself, does the current understanding and the computer model, by the way, as a scientist, you have to ask a simple question. Is it good enough? So, how do I say that why this climate model is simply not good enough, especially in terms of making the prescription that we have to cut the carbon dioxide, and therefore what happened? Climate will not change. No more hurricane, no more polar bear dying, no more sea ice melting or growing, no more ice ages. What is it? It's actually none of that, because the climate model is just simply inadequate. It simply cannot supply the answer. Mostly related to our lack of understanding, mostly also related to what we have not able to account for in the climate model. It's very simple. You take a sphere. You try to create what you call grid boxes of certain sizes. So on the what you call X and Y axis, you have something like 100 kilometers by 500 kilometers. And then on the vertical part, you maybe have all the other 1 kilometers. So you try to build the climate model in this three-dimensional sphere. And then you try to put in some equations, right? Mathematical equations, just basically to track all the heat going one place, or going to the ocean, or going to north and south, and going to the west when the wind is blowing, and all that. You try to account for all of that. But the problem is, we really don't understand how the ocean works well enough. We don't understand how the cloud works well enough. Never mind that. You can ask some very basic question. Does the climate model even include the effects of the moon? Moon is our nearest neighbor. It's very important. Just go out to the coastal area, you will see. Stand there. Sorry, don't be a Mark Twain guy. You just stand there and watch the tide coming in and out. You will see that the tide is influencing that. By the way, for those who say that the tide have nothing to do with the climate system, good luck, because it does. Okay, the tidal effect is fairly important. It makes how the water in the coastal area shallow, taller and broader. In some places like Bay of Fundy in Canada, what you guys want to know what the tide level is of the order of 100 meters. This is that big of changes, okay? So it depends on where you are. These things are very, very important for local and regional climate, okay? And it's really, really important to have it right. So again, that's why the analogy of knife and this chopping knife and this model is just nowhere close, because it's missing, first of all the physics, the chemistry and biology, because the famous physicist from Princeton at Institute of Advanced Study, where Professor Albert Einstein is, a professor named Freeman Dyson, who by the way doesn't have a PhD, but he doesn't need a PhD because he's smart enough, he's thinking. He often say that computer climate may be reasonable in the sense of how they try to solve this physics and mathematical problem. But what they're lacking is basically trees and fish and all this other biological life in the system. They don't have that. Because if you start talking about atmospheric carbon dioxide, you immediately run into the trouble is that what is governing the level of carbon dioxide in the system? It's actually the biosphere. This is what we need. And they haven't been even come close to try to model those things or put something into their model so that you can account for that aspect of the problem. So in the overall picture, to put a long story short, computer model is really, really terrible in the sense of being able to tell you anything, I'm sorry, because it wouldn't even tell you the season in that sense, because there was a long argument, by the way. I have met a great professor by the name of Professor Alan Robock. He's at Rutgers University now. He was extremely arrogant. He come up to me, but the computer model no seasonal cycles. I say, no, not really. Show me which computer model that can predict the seasonal cycles. Show me. Because we already learned the hard way. We know that trying to predict winter, how harsh or how strong it is very, very strongly dependent on how well you understand the system. You know, the next summer, you want to predict the droughts, the seasonal droughts. We know summer is coming. That's all we know. But I'm sorry, do you know how much rain you're going to get in Texas, or how much snow you're going to get in Canada, Montreal? What are you talking about? You actually don't. One of the most key elements about this aspect of overusing or abuse of the computer climate model is actually the arrogance. The arrogance of the practitioner, and mainly because perhaps they are too eager to sell their products, flawed products, to the policymaker, saying that, well, we know this, we know how to handle. Willie Soon, he doesn't know physics. He never take a physics class. He's not even anything. He's just a corrupted guy. But heck, I'm serious as hell about all this model having problems. Okay? They are not capable of even studying just the effect of rising atmospheric carbon dioxide, because you know why? They're not able to handle so many things, including, like I mentioned, cloud very quickly. Never mind even the complexity of cloud field, how you form cloud from water vapor, from ice, from downdraft. Basically, motion is also very important. So because if you look near coastal region of all the continents, that's where most of the clouds are formed, simply because of the land-sea boundary where you have downdraft, basically, is to form a very stable inversion of the temperature, so you can have this sort of moisture to trap there. Instead, it ultimately will form cloud, right? That's basically some of this stuff that, yes, the physics is understand, we try to model it, we did the best we can, you can cry all you want, but it doesn't matter. When it comes down to actually what the measurements say and what the model produce, the model failed 100%. It's not 99%, 100%. So therefore, the computer climate model have no use or whatsoever, you know, for that class of problem. We're just unable to do that. I do want to make a very strong point. It's a very different one from, let's say, numerical weather prediction. This is where the mismatches of knowledge and actually the limited use of numerical weather model, or it's essentially a climate model now. It's the same class of model. What they did is a very different thing. They are simply trying to see how the system, the climate system, from a given current state, now, presently, we have enough information. We fed in all the satellite information, anything that we have observation, as much as we can. And then we try to let so-called the equation evolve. Again, you don't account for biology, but good enough in the sense that the system has some inertia, so it remembers something. Okay, if the wind starts going here, it cannot all of a sudden go left, go right. No, not so simple, right? So you try to use the equation in a proper way. Those are the good use. And for some of the more sophisticated audience, you may understand already, all these weather forecasts, they were always telling you that we are only good up to, why do they only show a week? Not because they don't want to show you the next month. It's just simply because this numerical weather prediction has a strong limit of not knowing something ahead of time without given the current condition. So they are only able to integrate this equation and this model up to, let's say, 2 weeks ahead of time. That's about it, right? I mean, this is why doing weather versus a model is completely different beast. And the arrogance of those so-called climate modelers and all this what you call DAW alarmists is indeed, they fall into the trap of their own self-delusion, if I may say so, for failing to acknowledge that actually their climate models is not worthy of that process. And my criticism comes with a very strong experience, because I have personally built some climate model myself. And because That's the best way to understand. You don't criticize something until you try to make an attempt. So can Willie Soon make the best model that can predict the future? No, I cannot, because it's just too hard of a problem. At least I admit that problem, but I'm not going to sell to the politician or just because I want to get more grant that I know how to solve the problem and the problem is already solved. Interestingly, the problem is already solved. Please stop the funding. That's where the DAW people will be very, very scared, because they're going to say, no, we need to add in one more component. We forgot the tree. We forgot this. We forgot that. We're going to add this individual component. That's how they sell it. And to do science in such an hodgepodge manner is really scary in that sense. It's really damaging for the whole general problem of science and how science should be treated and how science should really work, not be corrupted by any other forces except for evidence and truth.
Good.
Let me go backward now, right? Start with, let's say, ocean. We want to understand sea level. I don't know how many audience really know that the computer climate model cannot actually calculate the sea level correctly. Simply because the model doesn't conserve mass. So essentially, if you're even trying to understand how the ice sheets melted and drop into, they don't conserve mass. It's as simple as that. This is why it's actually, they have to do a lot of fake work to try to pretend to say that they know how to do this climate model, this sea level changes. In terms of computing requirement, yes, that's part of the problem, but I always consider physics to be a harder headache. Computing wise, think about the problem that we need to resolve. We need to resolve something of a globe, right? Globe we know is about 6,378 kilometers in terms of radius, so 12,000 or so. You have to go from that scale of 20,000 kilometers down to a continent, a grade, and then you got down to clouds, and then you down to even ice particle in the physics, which is 10 to the minus 6, they are in micron. Some processes you need to know 10 to the minus 9, which is in the nano region, right? Dust particles, so all this fine dust particle even. We're talking about, well, 10 to the minus 9 to, let's say, 10 to the 3, 10 to the 4. So you got 15 orders of magnitude. This is called 10 to the power, right? So hopefully people know 10 to the power of 1 means, a factor of 10, that sort of thing. So you have 15 orders of magnitude. And if you actually work towards a physics of trying to call scale resolve, which means you resolve all of this physics. There is a cute number that my friend, Professor Christopher X, computed to say if you want to account for that, let the computer have the head to count these things. You will come up with a number of, that the amount of computing time you really needed to calculate the climate or the weather for 1 year even. You will need about, I forget the exact number, but it's 10 to the 20 years at least, computing time. So that will be, the age of the universe is only like 15 billion years, so 10 to the 15, 10 to the 9, you are already another 10,000 times or 100,000 times over the time that you actually have. So it tells you, in terms of scale resolved physics, by the way, I believe that is wrong direction. Simply because I really think that to solve the physical problem, you understand the problem transfer into another class of problem, which is really related to interactions. More through the interaction physics, which is a lot probably simpler. So it's really about changing paradigm. It's not a late hard force, wanted to solve this physics scale problem. Remember, Professor Freeman Dyson has reminded us about the complexity of the issues, mainly that maybe some governing biology is more dominant, right? Then you can simplify a lot of the problem if it were to be true. It is true, right? And that sort of problem. In fact, people even study about, bacteria. You would think bacteria have nothing to do with clouds. Yes, they can. They survive. Some of the bacteria can survive even cloud as high as the high cloud, which is of the order of 8 kilometers. They have already detected biogenic origin of those things. Those things, remember, marine boundary layer, marine, is full of all these animals, all this tiny little stuff. They can track all this behavior of all this little life form actually. are involved somehow. There is a new school of thought talking about El Nino being affected by this sort of thing. So we're dealing with a class of problem that's simply too big for any computer and any human mind to attack so far. So it is both. To summarize, it's really related to computing power. Not quite, I would say it's the interacting problem. It's basically the class of the problem is too large for us to tackle, especially, by the way, this one I had to make strong emphasis. I hope that of all the things that I say, you get across the essence of what I just tried to say to you. Is that, I mentioned even bacteria in ice. I mentioned dust, probably I didn't mention so many more things. That these people are suggesting that you don't need to know any of this. All you need to know is this one single variable called carbon dioxide. Remind you again. That's carbon dioxide breathing out. And they say by just knowing that, you will understand how the climate system will change. This paradigm, by the way, is not only flawed, it's already experimentally proven to be wrong. Over and over and over again. All the best measurements that we know now clearly are showing you that, especially last 20, 25 years or so, if you can measure something called a global temperature, by the way, measuring global temperature is another very difficult problem. It's another difficult proposition. It's easier said than done. It's just not a matter of taking all the thermometers in the world and just average them. Then you can ask, what about the rest of the world, the ocean? Because there's only 30% on land and then the rest of it. Plus, all the ice region, you cannot have too much information there. And what are we going to do with it, right? So there is a class of problem. If you can measure, it's actually not showing it's warming. And the thing that worries the most for me as a scientist is that those facts has been shown. But some of you may realize the last 2 or 3 years, there is actual movement and actual evidence, actual published, peer-reviewed published paper of some of those so-called scientists to go as far as something that you will not believe. Because all of us believe in people good faith and goodwill. But they go around and start changing the data because it doesn't fit what their actually formal prediction. The measurement has been going flat, so they are predicted going warm. So you can imagine the trouble, right? Sweating, some of them I'll go sweating probably when at night. And they actually was changing the measurements to try to make it fit more closer to the theory. You would not have believed if we were to not have this class of problem arriving on this planet. It is a very strange thing because I would say maybe it's not the first time, but it's probably one of the biggest kind of problem and concern that any living soul should worry about. In the sense that you cannot allow science to go that crazy. To have science and scientists using the name of science, the good name of science really have some power that are able to help humanity in many ways. But to have a bunch of these scientists who actually go around trying to change the data to fit a theory, that is the most dangerous proposition we could ever have. And that's part of the reason why we all should be conversing. And actually, it's in the sense that I also invite those who actually don't believe in what I say, do not have to believe in what I say, just look it up. And then contact us where we can give you all the information. And also, especially those who actually are saying that we are those corrupted and all these people like Michael Mann, Gavin Schmidt, Al Gore. On camera now, I invite all of you to come and debate us and show your data and explain to us, because that's the only way that simply because, why? I have nothing to be afraid of. The only thing I'm afraid of is that people telling lies. That's it, including myself. Right? If I tell any lies to you, you tell me, show me. What lie did I tell? That's the most critical essence that we must bring this debate. If there is one, I would call it more discussion, because probably that those guys would never ever watch my video. But I would like to invite those who are still fairly remain neutral to keep that open mind and then challenge me on showing the proof, which we will, and to try to find the question and understanding for yourself. Ask yourself, is it decent for somebody to manipulate data? Right? Obviously, we don't agree with that. And those guys will say, no, we didn't do that. We have scientific justification. Really? That's when we can have the proper debate. I wanted to ask the question, why you correct it this way? How you do it? What are you talking about? Like measuring of the sea level. Can you really resolve the sea level in some millimeter per year and plus or minus 0.1 millimeter per year? That's the claim. It's so easy to make claim that cannot be substantiated in science. In fact, those are usually shot down easily. But in this field, it's one of the strangest things. It's not about shooting down, it's not showing intelligence, it's just ridiculous claim, by the way. To claim that you can measure the global sea level to the level of precision of 0.1 plus or minus whatever, 0.1 millimeter per year. That is, can I pull my hair out? I don't have much hair, shave my hair. 1 millimeter is thinner than that, okay? It's about the tip of your pencil, if you can visualize the millimeter kind of thing. It's just very tiny little amount, 0.1. I mean, this is 10 times smaller. So please, think about it. Measure with that precision over the whole globe. Al Gore, I need help. Please send money. How well we understand the past climate changes and variations and all this other stuff that is ever changing is actually try to ask the question that perhaps the climax is though it's complex, there's no doubt, but what is the most obvious aspect of the climate system that we know? Season, isn't it? Day and night. What is these two things related to? One is related to how the earth rotates, right? The second one is really related to the sun. Most of it is related to sunlight energy input to the system. So I've been studying the issues of how the sun affects the climate system for a very long time. I would say, well, you can more or less up to even 29 years now. It's a long time. I'm a slow learner, but then I want to be sure of what I'm learning, right? I don't want to spill something that is incorrect. So season is a very obvious thing. And how well we keep track of this season is we base on thermometer station basically, right? Or in the ocean, we try to measure something, especially when you have ships going around the world and they keep track of information. You know how warm the surface temperature is. And this day we need to know in depth how the temperature or chemistry or salt and property, how it changes, right? So we collected more and more information, try to understand how it works. But it's very clear that the whole system is dominated by season, really. In fact, one of the aspects that is so interesting that now we have a class of data called the Argo buoy, ocean buoy. This is basically robots that actually sit on the surface of the surface and then go down to depth of almost like 2,000 meters. Just for clarification, the average depth of the world ocean is on the order of 3,800 meters, and we are only measuring first 2,000 meters. Go down for about a week and then come out and then relay the information. And we basically got close to about, I would say, 6,000-7,000 of this buoy around the world now. And they relay the information, so they're pretty accurate now. We have for the last 10-15 years, we have very good information. One of the most surprising things that this Argo buoy that is rarely talked about is that it's not only finding, let's say, something obvious like the season temperature changes of the surface, but one group from Japan published a paper long ago that no one noticed, that I noticed, that they actually found that down in 2,000 or 1,800 meters or so, within that region, you know, the nearest the end of the data. By the way, the reason why you cannot go deeper is because the pressure gets too strong, so they need to have a better equipment. That's part of the problem, right? The ocean can squeeze everything, so you got a lot of problem. And they found actually in the middle of the Pacific, it's not near any coastal region, but they found that the temperature there was doing this seasonal stuff. That is the deepest puzzle. Because it cannot be explained even by the sunlight. Sunlight doesn't penetrate the top 100 meters of the ocean. That actually, I kind of spoke quickly, so I reverse engineering. In the beginning, I was studying how the sun radiation, you know, with the sun and Earth orbit going around and then changing the seasonal sunlight, and then how the intrinsic changes of the sun itself, caused by the magnetism in the sun, is changing this output, the light output. So how they projected on the Earth's climate system. That was the beginning of just about everyone who wants to study this topic. But lately, I want to point it out that this Argo data, it clearly shows you that all this direction that took me about 20 years, so my last 9 years is smarter than now, the 20 years, first 20 years, is to realize that that is not adequate. Just treating the cluster problem like that is not adequate. You have to treat how the whole system is coupled together. So the explanation of the best explanation of the seasonal cycle in that Central Pacific is actually related to magnetic output from the bottom of the ocean. And I was able to co-locate the location of those the strongest seasonal cycle, guess where it's located? It's near where the mid-ocean ridges is, where it's documented. Information on the mid-ocean ridges is very difficult to find, but we have now, beginning to have, simply because of interest in seismology, so that's another area. Remember, we're talking about climate system as a whole. You have to start even with solid earth physics, right? We have to know how the magma works, because we have to understand volcano, and then we have to understand not only the biology, mind you. So in that sense, I'm trying to say that the natural factor is overwhelmingly dominating the system. So my simple theory or empirical evidence to support how climate varies is basically the whole seasonal evolution of the system. So there's no, in my view, there is no, by the way, if you think of that aspect, ask yourself the question, when you throw in increase more or less CO2, how would it affect this thing? It's very hard to conceive of a way in which that it can change the season, because what the sun is doing, it dominates everything. The sun supplies 99% of all our net, 0.5 basically. The little point something is basically from radiogenic heat, from uranium and things like that. So in terms of energy of the whole budget of the whole system, there's just no way that this carbon dioxide would come into the energy budget and affect it somehow. No matter how you want to model it. The only way is to do it by cheating, obviously. You just treat everything else not changing, and then change the carbon dioxide, change how you change the rate of the atmosphere cool itself. That's basically what the role of atmospheric carbon dioxide do to the system. It doesn't change the energy. It can only reduce the rate of cooling. So therefore, when you reduce the rate of cooling, you turn it around, of course it's warming, right? But how it can change the rate of cooling is completely controlled by how much energy you coming and not going by the sun. That's why this is why no wonder that it is almost like a truism, a very strong truism, although as a scientist you don't want to have any belief that the sun has to have some role. It's basically a scientist's role to try to figure out. This whole thing has been in a long time. I mean, the ideas of season come from the word climate. The word climate comes from the Greek word klima. It's actually related to sun angle of the sun, especially in the mid-90s, mid-80s. That every time you try to model the whole atmosphere and never mind the ocean, just the atmospheric problem, that I say that the atmosphere, in terms of layer, you have a region called troposphere, that's 10 kilometers or so. And then you have, let's say, 10 to 50, which is the stratosphere. You never understand why is it. Actually, you cannot know, but you have this general problem that hasn't been solved from day zero. The first day this computer climate model come out, is that you measure the temperature in the stratosphere. You will always find that the computer output, that you run this computer output, is always colder than what is being measured, which meaning that there's a general problem in the atmosphere. What most scientists, serious scientists, has concluded is that basically the climate model doesn't have enough wave heating. You can imagine the wind they hit on some topography, some mountainside. You generate some specific wave. Those wave is not adequately modeled. That's another problem. This is why they have this general problem that has to be fixed before you even begin talking about anything, right? This is why, in fact, if to put it in context, most people say that, okay, you put CO2 in the atmosphere, you warm the temperature in the troposphere by a few degrees, right? Temperature Celsius. And you ask yourself, what is all this general coolness problem? How much of a difference? They are of the order of 20 degrees, at least. So we're talking about something that really a big one that we have to really deal with this first. It just simply must not be allowed. But the problem is that all these clever computer climate models and all these IPCC's activists just sweep this under the floor. They say we know the problem. I remember vividly as a postdoctoral fellow giving one of these prestigious invited speech in Tenerife in Spain, where I scheduled to be a speaker, and I talk about this general Conan's problem in climate model, just to allude the whole community in solar physics, including some earth sciences people, because that meeting was all about that. And back then he was the IPCC chairman, Sir John Houghton, raised his hand and complained to the whole audience as if that he's right. Why are you talking about this problem? We knew this problem for a long time. And as a young postdoc, I say, excuse me, sir, this problem has not been fixed, so I'm very worried. Here it goes, right? Who's right, who's wrong? Why would a IPCC chairman would say that this problem is not solved, it's okay, we know about it. Okay, just because you know about it, that just simply tells you how weak this computer climate model as a tool is. It's never been a tool. It's always been something to teach you about how the system, so it is a pedagogical aspect of this, how you use the computer model, but not even for understanding, simply because we don't know it yet, right? Because you need a lot more empirical understanding, collecting from all different kind of areas of observation that I told you about. The ocean buoy from the most sophisticated type to nowadays all these studies about paleoclimate, right? And my specific area is, of course, how the sun affects the whole climate system. Yes, indeed. Through all this work that I did, by the way, it's very, very important. I got to take another step back. Really, really important. This is because the nature of how we acquire the information of what the temperature is on the climate system has been defined by this thing called the thermometer station, right? We have good 150 years or 100 years sort of data since 1850 or starting from 1900, pick the beginning, doesn't matter. Today, we have some data. And then you ask yourself, how good is this data to allow you to study the climate? You know, temperature, after all, is part of the climate, right? Remember, climate is more complicated than temperature, there's no doubt about it. But with these two great colleagues from Ireland, by the name of Ronan and Michael Connolly, we've been systematically, and of course, many contributions from important colleagues like Professor Peter O'Neill and some of our Chinese colleagues in China. And we've been, and of course, the great friend of us, Anthony Watts, who's been working very hard on quantifying, classifying how this thermometer station across USA, are they fulfilling what you call the NOAA standard, the National Oceanic Administration, which is in charge of measurements, whether they fulfill the standard that the thermometer station has to be like how many 1.5 meters above some clearings. That's on, so on and so forth, the quality of the data, so that we can try to pull out something called the climate part of the temperature data, because most of the time the thermometer is not measuring climate because it's affected by all the changes in the local environment, like pavement on the site. For example, the famous one is basically putting a thermometer station in one of the areas somewhere in California near the fire station, and then put near the exhaust pipe of the engine, whatever. All that problem. Tell me you can use the data to study climate? Absolutely not, isn't it? It will be a laughing stock. And these are the climate, this is why the problem of what we have today is that most scientists did not want to challenge those things. And then they also did not want to study the issue for themselves. They just simply relegating the authority. In fact, science have no authority, I'm sorry. That's the golden rule is the measurement, what the good data say. I mean, data is also have to classify in good data versus bad data. All the thermometer data is so difficult that you barely can use it to study climate. This is why when they claim the global warming is real, this and that, all this argument is a bit of a joke, right? Because they've been changing the data, first of all, and they're also using bad data. So therefore, it's a bit of a gobbledygook. These people don't even know what they're doing. Essentially, this is how the danger of the whole thing is. Most of these laymen, including all these thousands of Nobel Prize winners, from these economic people who never understand what the thermometer data is being acquired, and they just refuse to look at the data, refuse to say that there's something wrong here, which is easily shown. I mean, my God, I should invite every single one of those Nobel Prize people to come. I'll show you all the thermometer data that's bad. Go look and tell me what you can use with this. Why are you so confident, saying that you must have a prescription, cutting the carbon dioxide and solve the problem? No, it doesn't work that way. It has to, whoever that make that claim, you better show me that they got the data right. So, long story short, We work extremely hard to try to resolve this issue. So we have papers after papers. Now we are up to our third and fourth papers. We're going to keep producing some papers simply to try to explain and then try to tease out the part where it's contaminated by non-climatic factors, and then those climatic factors that we can use to interpret and then try to model. And the bottom line that you wanted to know is that if you want to explain what this temperature record has been doing over the past 150 or 100 years or so, we can demonstrate and show and calculate and so on and so forth. That is largely explained by how the sun's irradiance has been changing over time. And again, that doesn't mean the end of the story. The only thing that we say is that it will be extremely difficult to disprove the idea that the sun causes all these changes. That's the essence of the science. We're not there to prove a positive. We're trying to show that it's just very difficult to say the sun has nothing to do with it. It's a very difficult question. It's a bit controversial. I myself had dug very deeply into this topic on and off at least 20 years, minimum. The reason why I don't get into the topic yet simply because I've been tied up with too many issues, and this seems to be controversial enough that if I were to, it's the worst thing that it can do to a scientist, that you're afraid to ask a question. That happens to me, simply because the issue is so politicized. But I can assure the audience that this whole problem is not solved. So let me try to explain how I best understand this global carbon budget, CO2 budget, right? It is actually, I call it a puzzle, that essentially, if you ask yourself, where is all this carbon reside in the whole system, right? The amount is estimated to be of the order of 750 to 800 gigaton. 7 to 800 here. And ask yourself, where's the rest of it? It's sitting in the ocean, ocean sediment, soil, trees and plants and all this other stuff. Human. We are carbon-based material, boy. Okay? And the puzzle is indeed, and of course, what is the amount? The amount is huge. Huge in the President Donald Trump way of saying it. Is that these things is of the order of thousands, tens of thousands and hundreds and thousands of gigaton versus 800. So, why is it that there's so little amount where the system is actually saturated with this carbon, right? Because we're all carbon-based. And that's the puzzle. That's the real scientific mystery. And the way that the IPCC school versus, let's say, the most promising work that I've seen so far is from Professor Herman Hardy from Helmut Schmidt University, is exactly what we just say, that we realize that the system is dominated by season. If you ask yourself, how much does the forest emit these fluxes of simply because of photosynthesis and then decay of the material over season? Those things are of the order of 200-300 gigaton per year on that, just that one little thing alone. We haven't even talked about the ocean yet, okay? I'm sorry, right? And the strong claim, I would say, unverified claim by IPCC school and all these dogmatic people. Okay, and it basically can be best typified by this group from Bern in Switzerland. They have a specific global carbon budget models that assume in science. Assumption is extremely important to understand what it means. They essentially have not accounted for these things, this breathing of the thing. And simply because they assume that whatever is emitted is going to be assimilated exactly. So if it's emitting, let's say, 255 gigaton in 1978, it will suck back 255. That's what they assume. In science, those assumptions, I think, one should allow to be challenged them. Please, give me a break. And according to those guys, you're not supposed to challenge them. This is why when Professor Herman Hardy published a very strong paper last year, 2017, he immediately came under attack, right? for questioning how the global carbon budget works. He actually can produce a model that doesn't require the carbon dioxide in the atmosphere to stay forever, like tens of thousands of years or even 100 years even. His modeling shows that the requirement for the atmospheric carbon budget to come in kind of balance with the rest of the reservoir, which is from, like I mentioned, ocean, deep ocean, coastal region, that's also store strong amount of carbon sediment, what have you. The whole system is very, active and reactive. So it's very dynamic in that sense. It's not sitting still and emit exactly 251, come back 251. Next year it's 255, come back 255. No such thing. And he pointed out to this way of modeling, and then he add a constant term to the equation to try to solve this whole problem. And he shows very clearly that to require the system come into balance, and then so that you don't have excessive carbon dioxide remaining in the atmosphere, because I told you the problem is why there are exactly only 800 or so, right? Not so much compared to the reservoir. So he shows that to not have excessive carbon dioxide in the atmosphere, you require the system to suck it back really quick, so you need only 4 years in resident time, which means on average, when this thing come out, the most you will have a chance to stay is 4 years, then you get pulled down again, and then get into one of these reservoirs, one way or another, ocean surface and what have you, right? And just like the ocean, if you warm it, just like your soda can, right? If you warm it up, the bubbles disappear. That's when you're going to drink still beer. You let it sit for 1 year, that beer I don't want to drink. I want to drink beer with a lot of carbon dioxide, right? And same with the ocean. If you warm it up, more carbon dioxide effuse. If it's slightly cooler, it will take in less. And for the IPCC type of model, they assume this thing must exactly balance. Nothing else matters. The only thing that matters is when we burn our carbon dioxide from our combustion of our cars, and even in cookings and all kinds of things, that this is the only thing that contributes to the rise. But Professor Hardy shows that you can fit their results as good as anything else, but lead to a very different, dramatically different conclusion, where the atmospheric resident time of the carbon dioxide is extremely quick. I understand why these people are confused, and also wanted to say that this is one of the problems. I have to say, if all my understanding of this subject, I believe, again, it's a very bad thing for me to say that, I believe that Professor Herman Hardy has the right to ask the question. Just like I wanted to ask this question. I don't have the talent to solve the problem, but Professor Hardy has solved it in some sense for us. And I have checked his work very carefully. It looks to be very high quality. And then so far, IPCC has not been able to find problem. And you know how they assert their claim that they are right? That he's illegitimate, he's not a climate scientist, the same old 9 yards about nonsense. That is not scientific argument. And worse yet, they allow a counter-scientific paper to be published and don't allow his reply to it. This is where the censorship beginning to come in. This is now we're talking about science censorship, another area of domain that is highly flawed and one of those very consequential problem of how when you politicize science. We don't want to get into that. Let me just finish it. I really think that this global budget question is all completely unresolved. Simply because of all this simple point that I tried to point to you about. And one more thing that I apparently that not many people even thought about it. Every time when they say that human emit about 8 gigaton, okay? Actually 6 of them is supposed to come from this burning of fossil fuel. There are 2 additional gigaton that they claim is responsible by chopping down of the tree. I've been puzzled by that claim for a very long time, for a simple reason. I hope the audience will get it. Chopping down of the tree. I always ask myself, why would any people in any decent mind add the 2 to the 6? That's a very different process. Chopping down a tree only reduce your sink, which means there's no sink to it, which means when there are CO2, it won't come down. But it didn't cause as a source. So how do you actually add the 2 so conveniently? By the way, I have dug very deep into this area of forestation, reforestation and all that. if you think that they can account for the 2 gigaton per year for that forest land changes, good luck. It's not true. It's clearly a problem. Another problem is that it's been found recently that large part of the world desert is actually a net source of atmospheric carbon dioxide. And part of the secret is that most of the ground of the sand has some water somehow. And that apparently is enough for some biological life form to govern this stuff. That is one of the most surprising things if you actively ask questions. And this is where I try to say that these whole issues are not resolved. It's a mistake. It's a big, big mistake. This is where the problem is. Because they have a policy prescription. This is the way that in which that I felt that the world is going into a very wrong path. Like Al Gore asked me, do you mean that you're going to challenge this 2,000 IPCC scientists for getting things wrong? And you, who are you? Willie Soon, that's all I am. Willie Soon, who are you? Willie Soon. Are you going to challenge this 2,000 scientists? Yes, I am, I say. I simply don't understand the question. Do you, Al Gore? Can you explain to me? How does it work? Right? There are so many of these questions that's fully unresolved. Pretending that it's solved just because you want to propose your policy solution is extremely foolish and dangerous, really. In fact, the only experimental evidence that exists today about the impact of the carbon dioxide rising, that one no one is challenged. That one we all agree, by the way. We just don't know what source it is, right? At least I would say I don't know. Oh, when you say you don't know, they say, oh, you are so bad. You must be taking money all over the place. You must be really corrupted. You really want to kill your children. Every day you wake up in the morning, you want to kill your children somehow. But they didn't ask, right? They didn't ask exactly the right question that I asked Al Gore. The only evidence we have of the impact of atmospheric carbon dioxide is that the planet is greener. That's the only evidence. We cannot measure in the temperature. Can you believe it? That's about the best summary you could have of the system. Because atmospheric carbon dioxide ultimately is plant food and is very stimulating for biosphere. And that has been known for a long time from biology. But of course, the IPCC school is able to contaminate all the biological sphere, invoking science, this and that, National Academy of Science, Nobel Prize. No wonder they're powerful, right? And then they keep saying, are you willing to challenge? Why are you challenging? Who are you? That sort of thing. No, science is like that. It doesn't matter what you are, no matter how crazy you are, or beautiful or dirty or whatever. It's what the facts are. When the facts is not, going along your way, you better step back. So they have not been able to explain. Al Gore has not answered my question about cutting the carbon dioxide down and you're going to harm the biosphere. Are you going to be responsible for it, Mr. Gore? He clearly do not want to answer that, right? All he wants to do is that he wants to cut carbon dioxide. By the way, the great Freeman Dyson also say that he's afraid that ultimately China is going to charge us something for the free CO2 that they emit that is going to come here. He basically was worried about that problem. I say, Freeman, that's not a problem in that sense. Because it's food. It's basically a fertilizer for the atmosphere. And why would you want to cut it down? You have to ask a serious question. Why you cut it down? And also cut it down. Can you change the weather pattern? Can you change the atmosphere? They keep understanding. They keep cast it in some very strange and pseudo-science. I say pseudo-science simply because I just show and discuss that they haven't got the science right. They cast it in some probabilistic terms and all this other strange voodoo language, including even polluting all the IPCC about saying about confident level, the statement that we are 100% sure is 99% confident, 95% confident. Those are all sociology and actually pseudoscience. They are not science. And they have been corrupting every area and every aspect of the question, that they don't allow free thinking, doesn't allow free inquiry, doesn't allow free press in some sense, because they want to silence all of us just in case nobody can hear us. So perhaps that is better in the echo chambers that they built for themselves, which is really a big problem. the Earth and the Sun, together with all these other planets, we already know that other planets affect how our orbits is changing over much longer time scale. So it's on the order of what they call the Milankovitch, right, time scale. Those things will affect how our orbit tilt from 23.5 to about 24, and then how the orbit precess, like a spinning tops. Sometimes, like 11,000 years ago, now we basically have the winter. We are furthest away, we are nearest to the sun, right? But 11,000 years ago, our nearest distance to the sun is during summer, right? So those precession, and then the changing of the shapes of the orbits, which is either more elliptical, which is almost 4% to perfect sphere, a circle, which is a circle, right? That's 4% kind of change, and that is over 100,000 year time scale and 400,000 year time scale. Those regularity come from basically Jupiter, Saturn, and all this other stuff, including even inner planets. Like, for example, Venus is causing our stuff to modulate about 1.6 years. Okay, so we're talking about things that changes over this whole continuous spectrum. This is why to study this class of problem, you really have to be very broad-minded and broad disciplined, because it takes that sort of different solutions to try to put together the more comprehensive picture. So that has always been my goal from day zero. So it's doubly disappointing when you come into a new area and realizing that these people only want to study carbon dioxide, which is really strange. So let me start. So you really need to know how the orbit changes over time. And then not only that, I have known this problem for a long time, that on every few years, first of all, season, 1 year, right, 365 point some days, and then plus that you have this, what you call the odd even leap years and all that business. That's why keeping calendar is very difficult problem. You need accuracy. 1 year, and then you realize that all the short time scale, interannual time scale, so every 2 years, every 3 years, if you like El Nino, we need to know, is El Nino truly something that's changing internally to the system, or there's something not so apparent from the outside? That's the question I want to answer. And it turns out that our orbits have enough of a signal and regularity in this multi-annual timescale to the issues of decades, to the issues of 60-year, multi-decades, to the issues of centennial, to the issue of bicentennial. Those are specific time because they are related to how the orbit perturbs our relative changes to the thing. Plus the moon, don't forget, the moon. Because the way the sun see our system is actually not the earth only, it see both. Because the sun have a tidal effect on us and the moon have a tidal effect on us. So these things are inseparable. This is the class of problem that no wonder you cannot trust the climate model, right? Only for weather prediction you can do that. But if you want to understand tide, I'm sorry, you have to have moon, right? Not only that, you have to have sun. Sun have a solar tide on us also. Especially if we really want to understand atmospheric phenomenon in the ionosphere. Those things are all really relevant. On top of that, the sun itself is a giant hot gas ball, right? Deep inside, you have this nuclear generating core that is on the order of inner 20%, 10 to 20%, so of the inner core. It's basically so dense and so high temperature that you have hydrogen fusing and forming deuterium, and then two deuterium form this thing to make helium. So out of it, basically where helium come from. It's from internal of the core. Then you have an outer region where mostly a reaction to this. So you form a region. There's another 30% of this thing, so 40% or so. It's called a radiative transport zone, where all the energy, because it's so dense, the photon, by the way, doesn't get seen from the outside. It takes bouncing around because it's so dense that it bounces around at least 100,000 years. By the way, the time scale is so strange because it's exactly coincide with the Milankovitch time scale of 100,000 years. And then another outer region, which is the way in which the sun cools itself. Sorry, when you have a heat source inside, the internal core is this nuclear generating part. This is where the source of the luminous sky is basically from the energy that is powered by nuclear fusion. It's a fusion of basically hydrogen into deuterium, deuterium into helium, right? So you actually produce helium that settle into the core, by the way. So there's a small diffusion process. So there's some already certain amount of helium in it, in the inner core, that we shall never see until you can chop open the sun, of course. Then you get the outer region, which is a reaction to this hot ball and dense region, slightly more rarefied. Gravity is still important. And you have this region that is, the mode of the energy transport is by radiative transfer. So it's called radiative zone. Okay. And it turns out that this ball is so solidly rotating, it's very, very hard to make sure that, see that it's differentially rotating. So it's equal from pole to equator on this region. That's information we have from helioseismology, basically sound wave propagating. And outer region is really the reactive region. It's called the convective zone, where the energy is transported by fluid, actual flow, plasma flow, right? Basically hot stuff have to warm up and then cool stuff sink. That's the idea, right? Essentially you form, and then we're a narrow region. And then not only that, the reason why magnetic fields got generated is because the sun on the outer surface is differentially rotating. On the equator is about 27 days, on the pole is 40 days. This slow stuff, if you imagine you have a seed magnetic field, it wind up, right? It's wind up, right? And then through turbulence of the atmosphere, you have this what you call helical flow. They're called alpha effect. That you actually, these are very small scale, by the way. Stuff that we're talking about is basically the whole hemisphere of the sun. The heliosphere, I don't think we ever resolved them. It's on the much, much smaller scale that you can resolve really, because we never detected the helical scale really. It's all in conceptual state. That is called alpha omega model. One is the alpha is the helical, omega is actually the differential rotation. These two effects, whether it's operating on the surface or near the bottom, the transition region between the radiative zone and the convective zone is called tachocline, by the way. There's a technical name for that. That's why the different, solid rotation inside. Twisting if there's a magnetic field, it twists it up, wind it up. And then allow the expulsion of this magnetic flux, because when you build up, the flux there is of the order of kilogauss. On the surface is only on the order of gauss, and then in the concentrated region where the sunspot appears, that's also kilogauss. Sorry, 100,000 kilogauss in the tachocline, those field. So they have to buoyantly go up, right? So that's basically the phenomenon of sunspot. And if you plot those phenomena of sunspot over time, it look like a magnetic wave actually, a wave. That's why it is described as a wave. It look like a butterfly wing, that very broad from 40, 45 degrees and then move towards the equator. This is where they're describing the sunspot cycle. But we found out already in 1908, George Ellery Hill at Mount Wilson Observatory. The time in which that we haven't got the Zeeman effect figured out, which is to detect on quantum mechanics sense that you have a spectral line. If the magnetic field is present, you split the line above and beyond what is being perturbed by pressure and all these other forces, but magnetic forces does that. So Peter Zeeman from Holland figured that out experimentally, and quantum mechanics you can easily after that realize and show these effects to be real magnetic presence of this. And 1908, George Ellery Hill at Mount Wilson they started taking picture and then put a slit of this spectrograph and show some particular line that is sensitive. Actually is iron, one of the iron line that shows that it's actually in the visible wavelength, because that's when we can do at that time. It's about 6,000 angstrom, and 6,000 by the way is a visible part about that, but it's slightly green, and they were able to show that they can find Zeeman effects. And the amount of split depends on the strength of the magnetic field. So early on, we already realized all this magnetic region, the dark spot region, in Latin is called maculae, M-A-C-U-L-A-E, right? And then the bright part is called faculae. It's like torch. Black one, I don't know what it means, but it means black spot probably, something dark. And that we figured out that it's strongly magnetic field region. Not only that, he figured out that magnetic field, you have to have polarity, right? Which means you have direction. So you figure out that this sunspot is actually one time is positively region, positive, and then the other side is going in, the other side is going out. So it's actually a 22 years magnetic wave cycle. That's basic understanding. The best bet after studying for many, many years, once the equation was found, essentially created by a guy like Eugene Parker, for example, to make the postulate that we can actually concisely define this system. The whole idea in search of mathematical science and physical sciences is try to understand this phenomenon, right? We have great observation to lead us, like Halileo Hill and then Monders and a bunch of those people. The Edward Monders and Annie Monders are this very famous observer of the sun. I call them solar observer. Very dedicated. They actually took the first photograph of the sun right around 1876 or so, until the year that he retired, 1928, and the year he died also around that time. He took that photo, and then it's been taken on by US Air Force till 1976. Now the program died, and then there's another group in Kitt Peak and Sack Peak that continue the program. But those programs essentially by now, 2018, is died because they want to focus money on big program, which is really not a very good direction in my view. Too sexy, and it's just not going to be big gain for the money. Always about fighting resources. So, the sun. So, the sun. The problem now is how you integrate this magnetized ball. And by the way, sunspot come and go. Clearly that you can control the amount of light output, right? Because the amount is very tiny, by the way. It's of the order of 1% when the size of the dark area is small, even up to few percent actually, very large in instant. And then it's actually very small, of the order of 0.1% coverage. So it dimmed the light by that much, basically. But the problem of studying the sun is not studying the sunspot alone. Most of the problem is that since we are able to put the satellite up to do the measurement, mainly that we've been trying to understand how much the sunlight outputs have been changing, started by the Smithsonian Institution, by a guy named George Abbott in the early 1900s, who tried to do this institutionalize this program by the gift of James Smithson, this clockmaker, who tried to make us understanding the fundamental study where I am now at, Smithsonian Astrophysical Observatory. It's very sad that they tell me not to study the sun climate, which is really bothers me. But that's another side of the story. But it started by Abbott, and then Langley first, Samuel Langley, and then Abbott, and then another director of the Smithsonian, who've been actually trying to measure this light output. But they always been able to put only a telescope on top of the mountain tops. And that's not good enough, because the amount changes is so small that any changes in the transparency, which mean between Earth and the sun, like cloud, then all games are off. Essentially very hard to recover the information. So only when we go above the atmosphere, started with balloon stuff in the 50s and 60s, there were some measurements and really good effort trying to measure what the sunlight. Then we have satellites. Ever since then, we were able to confirm the facts that when the sun is more active, which means there are a lot of sunspot, so you can imagine what happened. A lot of sunspot. Shouldn't the light be dimmer? No. The sun get brighter. That was the first surprise of the satellite results. And there was no explanation immediately because people was just surprised. It turns out that it's not because of the sunspot that is really governing the effect of this light output. It's actually the smaller magnetic skew element called the facules, and there's another name called plages. Those are bright region on the sun that magnetize also. They are less concentrated in magnetic field, so they are order of 100 Gauss and even a few Gauss. But they are smaller region compared to sunspot. Sunspot, by the way, one sunspot can be, you can fit 3-4 Earths inside it, even Jupiter. It's big, okay, the region. So those big region are overcompensated by the light emission. So the sun gets more active. When you say the magnetic field of the sun is stronger, it gets stronger. So that was the first explanation, but the rough explanation is because of that, right? And then again, The usual IPCC school is to say that we have known everything. Willie Soon is always wrong. He's so stupid. He cannot do this, cannot do that, cannot study this, cannot start that, cannot ask question. I immediately asked the question, what would happen? So by the way, the satellite we can observe only about 3 so-called sunspot cycles. If you say that you studied 3 sunspot cycles for over 30 years, that's good enough to understand the sun, how it varies over 1,000 years or even hundreds years, Good luck. I don't think so. So we immediately asked the question, would the sun do anything different in the time like we know as Maunder minimum? When the sunspot, Maunder minimum is a period from 1645 to 1715. The most famous person during that time was so-called the Sun King, Louis XIV. Apparently, the rumor is that the Sun King appears so the sunspot hide away. They are scared of the Sun King. He was so powerful. That's only a legend, mind you. But that time, apparently we have enough information because, why? Thank God to Galileo Galilei and a bunch of those early pioneers. They started to realize that you can use telescope to monitor the sun. So they were actually using the telescope to watch sunspot, count sunspot, project it carefully and study that, including this Jesuit priest by the name of Christoph Scheiner. And then in England, you had a bunch of those good people also was measuring. So a few people around. And I found out that also the Asian, in China, Emperor of China was also very fond of studying the heavenly bodies. So there's a lot of information there, which is yet to be fully explored. So that's part of the work that I'm working with some Chinese colleagues. And thank God for them initiating the project. So the French were excited. All these scientists at Observatoire de Paris, who was formed at that time where people were trying to concentrate on zero longitude, how to find the clock. And they started this observatory to make what you call precision astronomy. That you try to define this, so they started observing the sun. To their great disappointment, they monitor the sun, but the sun doesn't seem to put out so many sunspots. So they actually initially thought that Galileo was lying. Better go check him. Better go check all this old record. What is going on? How can it be? Right? So it turns out that from that period, 1645, they observed, quite early on, 1630s, they got information. In fact, there's another husband and wife team from Poland. They were also observing them. And they found a lot of sunspots actually during early times. The Danish guy, one Danish observer was also observing that. So in fact, his name is Hevelius. Hevelius is actually the guy who is what you call the Polish astronomer, but he was living in Denmark somewhere. And they were observing this, and then they realized that the Paris Observatoire de Paris scientists are very careful. They map the relative location of the spot on the surface of the sun. They immediately realized that the sun is actually tilted on the orbital plane by 7 degrees. You can see all this map from Galileo's picture when I show in my talk. You will see this thing. And they show the map that sunspot didn't appear in the northern hemisphere of the sun. And then some sunspot does appear. It's not completely disappearing actually. Very small amount of sunspot appear, but they are not appearing in the usual location like 40 degrees, starting in 40, 50 degree, migrating down and have the butterfly wing. If you look at the plot of this butterfly wing, it's actually a broken butterfly wing in the sense that the left one is disappearing and then the right one appearing, but very narrow. It's like this. So my good colleagues, Professor Elizabeth Nam-Reeves, she was the one that actually encouraged me to study this about the sun. She's from Observatoire de Paris. She died very young, but a really good solar physicist. And went into the study of this. By the way, she estimated that the Maunder minimum to the present time, the sun irradiance could have changed on the order of 0.5% to 1%. Yeah, she estimated very early on. Guess what we found? Independently from our study of sun-like star, we can say anything from 0.2 to 0.7. The best probable mean is 0.4. I've done that with a graduate student from Harvard University. And we produced that work in 1994. It will never be able to be disproven. People say these jobs are all done, and it's just not true. That's the problem. So that was the goal, to try to understand how much the irradiance of the sun can change or not change, right? We need to understand it could, by all means, it could not change actually. But the point is that the fact that it's not changed is not viable because we have detected that it's changed. Not only that, the real interest about wonder minimum is that it so happened to form in one of the coldest periods on planet Earth. It's called Little Ice Age. Little Ice Age, in terms of the time extent, cover much longer time than wonder minimum. It was anywhere from 1300 to about 1900. So the coldest time on a lot of areas in Northern Hemisphere especially is around 1700. Like for example, our friend Willie Soon just showed a Scottish temperature record for the last 800 years, showing that the coldest period is about 1700 in Scotland, using one of the proxy. And the point is that why you call it Little Ice Age. It's not all about measurement of temperature. It's not that at all. It's actually the size of the glaciers all over the world grown to a maximum size actually. You can see the glaciers in New Zealand, the mountain tops in Argentina and forest area. You saw all of those evident all over the world. In fact, that was one of the things that got me into big trouble. By writing a paper that shows that this globalness of the Little Ice Age and the medieval warm period does exist, is real. It's been measured in so many of these archives, plus historical documentary, so many things. Angkor Wat, you can imagine medieval warm period. Angkor Wat was building there about 1,000 years ago, in civilization there. In forests in Argentina, you can see it extended another 100 or 200 kilometers south from what current position is. So many evidence that is so clear that this thing is real. And then the problem there was a guy named Michael Mann from University of Virginia in the beginning was making the claim that no, Little Ice Age, the temperature on the northern hemisphere didn't change at all. If it changed, it's only 0.1 degrees Celsius. That's 1 degree Celsius, too hot. It's too much. 0.1 is very, very difficult to measure, by the way. And these people claim that they can use this indirect 3-ring proxy to measure 0.1 degrees Celsius. You got to convince yourself whether that is true or not. But we published a paper to be honestly discussing the issue. And that's why the one that got me into quote-unquote political trouble, that I'm taking side and so on and so forth, has nothing to do with that. It's just simply trying to understand what is going on. Is what Michael Mann say is true or not true? That's about all you are interested in. Right? And that's when the study of the sun becoming a very problematic. I mean, for the social psychological reason and history of science reason that I have to mention this. Part of the reason why I published a paper in 2003 against Michael Mann's famous hockey stick paper is simply because that from the time period where his last paper in 1999 to about 2002 or so, that if you want to study natural climate change, natural really mean that it's not man-made, okay? That you want to study whether it can vary naturally and how large and how small. By the way, it's not interesting to just say that it can vary naturally. If it doesn't change like 0.1 degree, in terms of explaining what is wonder minimum and how the generation of magnetic field really works, we can only have what you call somewhat descriptive statement where we don't have any quantitative statement at all. Like, for example, we don't know how weak the magnetic field strength has become. All we know is that the usual hand-waving stuff is that something nonlinear happened, which is one of the weasel words. Nonlinear dynamics, all this nonsense. Is that somehow one of the factors, like the alpha effects, which is the helical flow, or the differential rotation, is not working as vigorously as it could be. In fact, you can show, of course, how the superposing of all these different dynamo wave get collapsed and can produce this sort of north-south asymmetry, for example. That's the most obvious feature of wonder minimum. How we wish, for example, one of the area that I'm very deep into now, because we found that the sun over the last 10,000 years has produced quite a lot of this minima, activity minima. We clearly identify another one that is well known. It's called the sporominima. Sporominima happens roughly from about, I would say, 1420 to about 1530. That was showed up very clearly and discussed very extensively in my most recent talk at Doctor for Disaster Preparedness. So that video, I hope somebody will watch it, in the sense of how that phenomenon that is known on the sun, by the way, we can actually confirm that in multiple measurements, mainly through the concept of measuring radioisotope like carbon-14 in 3 rings, or measuring stuff like called beryllium-10 and even nitrate concentration in ice core, where you can show that these are all related to extremely anomalous events on the sun to be able to produce such a signature on the Earth archive. Essentially all related to how the magnetic field generation works. So we know that minima and monominima. Now we like to know, for example, a simple question: how weak is monominimum? How weak is sporominimum? What is the relative difference between the two? Right? Unfortunately, we don't have a straight answer. As far as we can tell now, it's basically. And then, of course, never mind, the next question is how does that relate to the Earth phenomenon, right? And it clearly that, notice the time period, right? It's all related to the Little Ice Age phenomenon. So Little Ice Age, instead of being explained to be more volcanic eruption, could easily be comprehended and included by just the phenomenon of the sun weakening and multiple times separated by roughly 100 or 200 years, 180 years. By the way, that also feeds another phenomenon on the orbital forcing. So, in that whole quest for a comprehensive understanding, I don't think you can escape the conclusion that something about the sun has to be understood, right? I mean, clearly throughout this whole period, I mean, if you want to challenge yourself to think about the role of carbon dioxide in the system, I mean, you really cannot find it, isn't it? I mean, that's where the problem is, why this idea is not a theory. Again, I emphasize that this CO2 dangerous anthropogenic global warming idea is not a theory because it's never been falsifiable. And we all learn from the great lessons of some philosopher that if you cannot refute these things, it's not a theory. It's not even any scientific principle. It's not anything. It's just some strange ideas, pseudo-scientific ideas that crop up by somebody like Al Gore during his sleep, or I don't know, IPCC chairman. So this kind of problem needs to be cast in scientific form. This is what the work most of me and my colleagues are working on. Trying to understand, to get at, to better define this boundary condition. And of late, I realized that just the idea to try to understand how the sun and climate relation would not be complete without invoking another variable in the Earth system, which is basically how the tectonic system responds to it. In the sense that how is it related to volcanic output and even earthquake actually, because every time earthquake slip within boundaries and plates and stuff like that, you actually can also emit quite a lot of stuff, right? I mean, one of the most well-known stuff about volcanic eruption is actually not sulfur. It's the amount of water vapor that actually does get introduced into the atmosphere, right? And those stuff are all very difficult to quantify because each of the volcano has its own distinct feature. This is perhaps can also explain why there are so many varieties in terms of the volcanic output. The famous one from Mount Tambora in April of 1815 clearly produced this effect in the northern hemisphere, where we have winter, year without summer, right? In New England, for example. I mean, those phenomenon, I would venture to say, is really related to the solar activity. That falls into a period called the Dalton minimum, another famous period of minima, basically from, I would say, 1790 to 1820. It's much shorter duration, this one, right? Notice it's much shorter, 30-year period, but the activity phenomenon is documented in sunspot. Now we have direct observation, at least some information, and then we can also document that, all of that in all of this solar activity proxy, as I mentioned, either carbon-14 3 rings or beryllium-10, and we can see that thing in there, okay? And one of the things that I realized is that it's perhaps related to something even more exotic people claim Mount Tambora. Mount Tambora, clearly is not the sun doing that, isn't it? But I realized that it's related to something even more complex dynamics between how all the different planets is actually affecting the movement of the sun within the barycentric center of the solar system. So the notion that the sun is the center of the solar system is not true, right? Because the center is always moving around. Okay, actually, the amount of region of its moving is quite large. It's of the order of a few million kilometers. So you can imagine why this is not a trivial kind of answer. If it moved by 1 inch, okay, God, we don't have to say it's essentially standing still. But it's not by 1 inch. It's by millions of kilometers. Even the Earth and Venus, we are able to pull and push the sun by about 1600 kilometers in terms of its movement. So it's not trivial. These are all the effects I essentially have to quantify. And the whole idea is that I try to explain that we try to explain how the sun intrinsic variation caused by a dynamo wave. So with another colleagues of mine that is very, very smart from Argentina, we've been trying to incorporate a physics to this problem to see how is it that all these orbital effects could try to affect how the operation of the helical flow. Actually, we only model the helical flow because that's the best way in which best hope in which that we think all this gravitational effect would be able to impact, because it's on a smaller scale, right? It's a bit like a tidal effect, but it's not really tidal. Tidal effect is too small. And to affect the motion, then ultimately it feedback and then cause how the magnetic dynamo is being generated. And therefore, it feedback into the climate system, where during cold time you can imagine that you have more, maybe even more water loading on the thing, so will be related to tectonic response. That's a complete picture, but it's a hard problem. It's a hard problem because we don't have enough information. But I'm confident though, with this new sketch of work, it's not even a theory because again, it's not yet ready. But the whole idea is that to try to understand the whole system as a whole, my emphasis is always about a picture, a framework in which you can initiate some detailed study to try to go about refuting yourself in a way that is very healthy, that you can learn something from the mistake, even if you find a mistake, right? If it's true, so be it, right? So that's the kind of work that I think will be ultimately very rich and rewarding in terms of trying to gain some understanding of how the whole thing works. It's a theory that was born roughly around 1996. It's based on a work that is co-authored by Professor Heinrich Schweinmark and Igor Friis-Christensen, the late professor. He just passed away a month ago from Denmark. And what they were able to demonstrate in that era was very interesting and it got me really excited myself. It was about the idea that, they were able to show the interesting correlation between cosmic ray changes versus cloud cover changes. So let me put that all in context. The cosmic ray is measured in something what we call the neutron flux. Okay? And the cosmic ray intensity is inversely related to solar activity in the sense that as the solar wind is stronger, so when the activity is strong, the solar wind actually does get intensified and there's more magnetic flux expulsion. So this Earth is much more shielded against incoming cosmic ray. Cosmic ray, by the way, is nothing but very, very fast charged particle, mainly proton, really. There are a little bit of neutron because they are moved. There are a bit of other stuff, right? Alpha particles, which is the nuclei of the helium. But they are very small in terms of coming from space, but from the sun it's a lot more. And basically this solar wind is able to shield out when it's strong, so there's less cosmic ray coming in, So therefore your thing is no cosmic ray on the ground, right, when you measure. And the sun, solar wind is weak, then more cosmic ray coming in. So the cosmic ray peak at the solar minima, activity minima, just the opposite, right, when it's strong. And what they were able to show is that when you have peak cosmic ray incoming, and they were able to show that more cloud form. So when it's maxima, less cloud form. So that sort of fit into the paradigm, the ideas that maybe that this cosmic ray, because they are very fast incoming, they are not stopped by the Earth's magnetic field because we're not as strong compared to the solar wind. So they penetrate through, and they were able to cause ionization in the air, in the atmosphere, basically in the ground, in the office here, your office, your room. They are able to penetrate. What they do is that they ionize the air. They were able to strip electron of something, of the molecules, of the atom, if they're round. Strip that off, but because the air is so dense, this thing quickly get recombined. It's actually of the order of only milliseconds to 10,000 of a second. So that's why we don't see them. That's why the air is always neutral, because it quickly got back, because too much air around, right? So that makes hypothetical sense, because that one was kind of proposed already long ago by a person named Edward Ney from University of Minnesota in the 1950s, where they flew a lot of balloon, where they're trying to measure the property of cosmic ray. And they realized, in fact, I traced it back. The idea is not starting from Heinrich Schweimark and Friis-Christensen. You can trace all the way back to even Christian Birkeland and a bunch of those. There's a guy, I forgot the exact name, but he's from Denmark, by the way, coincidentally, was formulating the ideas in the 1900s. Christian Birkeland trip to the North Pole and all those regions is about 1903, I believe, the expedition. And they spent a year actually out there. They were doing all kinds of magneto measurement. At that time, they know something to measure that. And they were really proposing already. No, the guy's name is Paulson. I remember now. Paulson is spelled P-A-U-S-O-N, Paulson. This Danish scientist who already proposed that early on, that maybe it had to do with cosmic ray. That was very attractive. I like it very much. But the problem is that was shown for the data of the cloud from 83, 85 or so, because 83 they didn't have much data, 85 until about 1993 or 92. So you imagine, it's almost half a cycle, almost not a full cycle even. Very attractive. I was very excited. By 1997, I was a full supporter of this theory, this idea, this notion. In a sense, I also have to be fair. I wouldn't call it a theory anymore, because it's kind of untestable as of today because of politicization of science. That Heinrich Schweimark, God bless him, worked very hard. They continue this idea that maybe it's true, that this whole idea. But let me tell you my reservation on this topic. People may not like me after this, but so be it. I'm a scientist, so I speak my mind. Two problems. One of the biggest problem is that the cloud data that they use has continued since then. Let's say the project is called ISCIP, International Satellite Cloud Project, okay? Run by Bill Russell from NASA GIS. It measured at the first point, it's 83, and then it continued until 2003 or so, okay? So you can imagine, if you show the data from 92 or 93, that's where Schweimark stopped. He produced a paper in 96, so you have a lot more data. You show that, how does it compare? When you show that, all the relationship break down. There's no more correlation. So again, this is what it means by correlation. Doesn't mean causation, and one has to be careful. As a scientist, I'm highly critical. So in 2000, I actually make some effort to contact them and give comments to Schweimark, and Friis-Christensen is less involved, because ever since then, Schweimark ran on his own. Between he becoming a professor, he hired his own postdoc. We were trying to communicate with them, showing them that one of the papers they published in 1998 in Physical Review Letter is probably not correct. What I mainly claim is that maybe they misidentified the inverse relation between the cosmic ray versus the irradiance effect, because it's very well known. There's an inverse relation between solar activity and the cosmic ray. It could easily be, okay, that you have more or less cloud related to how much the sun irradiance affecting the water vapor output. That's simple as that. And they refused to listen to us. I tried to publish a comment in Physical Review Letter, but it was not published, but I have the paper. Anybody wants to read, it's fine. During that time, I become totally convinced the effect could not work because I realized that I talked to the person who generated the satellite ESCAPE project. Because Heinrich Schwarzmark since then have adjusted the data to change it a little bit. And by all reason, if it's true and if the satellite data people agree with that kind of adjustment, then I would agree with Schwarzmark. But unfortunately, this friend of mine who worked with me from Colorado State, Fort Collins, his name is Garrett Campbell, he did not agree with that. That's why he joined my paper, but they don't want to listen. That's a bit sad in that sense. That's just an empirical basis. What I mean is that the empirical basis for proposing this idea is not strong. That's one point. Second point is, in some sense, when you come in from another field, he's from space physics, and then there's another character by the name of Nershav, Professor Nershav, has also been thinking deep about this issue. But they're from astronomy and space physics. They really have studied the climate, that's true, but they really didn't want to think deeper. The problem, as I just say, is that the cloud field, what they are proposing is that this thing is controlled. The cloud formation is controlled by the microphysics. Remember now we're talking about nano-sized particle attaching to water droplets, so they build it up, ultimately make into size of a cloud. Cloud is on the order of, you can look out in your sky, on the order of a few hundred meters at least, right? To build entities, some of the boundary layer cloud is all. The problem is that they really miss the whole problem of how cloud get formed. I don't think it's formed by microphysics. It may work for this little patch of region, this big, by the way, this camera, this big. Small little region, because you can pack a lot of micrometer in this region. But you cannot possibly pack micrometers in the real cloud out there. Because most of the cloud are formed by fluid dynamics, by basically inversion process. I just pointed out that most of the marine low cloud, I would propose, one of the great misunderstanding about this cosmic ray cloud theory idea, is how cloud get formed. I would really strongly say that you really need a lot of this, what you call large-scale phenomenon. It's about fluid flow, it's about inversion, it's about downdraft, it's about water vapor availability. By the way, the idea that you have cloud charged particle to enhance the nuclei of some existing nuclei like aerosols particles, the marine boundary is producing enough nuclei. You have more than enough. Okay, but this is part of the real problem, that if you dig very deep, this theory doesn't hold. And they are very, by the way, I'm not underestimating Heinrich Schwarzmark. They've been studying this issue carefully also. But unfortunately, there's just a few of those things that they refuse to look at, refuse to think about it. They've been trying to find only evidence that support their ideas, but refuse to look at evidence that don't support their ideas, which is not a good thing, right? You really have to be open-minded in that sense. Although I know he tried very hard, he tried to build experimental tests to show, but most of the experimental tests are not very useful or insightful because it was all testing the microphysics. They are only testing the concept of how the enhanced charge on the electron will enhance nucleation. That one, I think you can show that, which is indeed you need to show that, obviously, but it's well known. Some of my good colleagues, this guy Fan Kuan Yu from University of Albany, who used to be a student of Richard Turgot from UCLA, he was among the early proponents. He also realized that by the way, they are trained in meteorology, so they realize also that most of this idea may not work. Simply because cloud doesn't get formed by microphysics. Just imagine things on, by the way, Heinrich Schwarzmark has gone so far to try to say that in terms of distribution of the particle size, they are really dealing with sub-nanoparticles. These are including people that in forestry. One of the most famous guy in that field is actually Kumala from Finland. They were able to convince the sun to do this experiment, this so-called cloud chamber experiment. It's not real cloud chamber, it's basically ultra clean lab. The aerosol community was completely bought into doing this experiment, which I don't mind actually, but I tell you it's not towards answering climate physics, it's to understand cloud aerosols. And because the cloud aerosol community never get enough money and momentum to build such a clean lab, so they want to test the different impurity, the chemical, ammonia, what have you, because if you talk about aerosols, it's not just sulfate aerosols. There are ammonia hydrate, this and that. There are a lot of this biological one. And there are up to 50 or 100 types of different types that they want to test all these different in the widest range of environment. I mean, isoprene, it could be considered aerosol. One of those. Those are all the big molecules that emitted by plants, right? That create this blue haze phenomenon. Reagan was heavily criticized when he said that the forest is actually polluting us if you think they're creating ozone. It's true. Blue haze phenomenon is very well known in West Virginia, in southern Australia. Those are from forests emitting all these particles, doing this sort of thing, right? I mean, I think to think that the cosmic ray are helping that, I don't think so. This is why a lot of this stuff doesn't fit. That's the whole problem. That's why I'm willing to abandon the idea for now. Because most of the evidence being brought forth is very, very weak. Not only that, it's contradictory. Even the most basic argument to support the original notion to go in that direction is all wrong. So you need to look back. No wonder that sometimes all this fist fight about IPCC doesn't include cosmic ray. I wouldn't even use that argument because it's not working for me. It's just not true. IPCC, by the way, has also claimed that they have evaluated the mechanism. They have already included that in the climate model, according to them. They were able to show that this cloud have no effects, okay? Blah, 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 blah. Both sides are wrong. So I come back to something more simple, which is exactly, all the energy is dumped in the form of radiant energy. So you have to consider that. You cannot escape that. It's the season that is doing most of these effects, intermediary. Not only that, the effects that we always wanted to find, the difference between interannual is of the order of only a few degree compared to your local regional stuff that is order of 30, 40, right? You know what I mean? Depends on what latitude you're on. Simple basic question on equator. The sun crosses the equator twice. What is the most dominant temperature signal in the equator? It's annual, not semi-annual. You're supposed to have double helm, isn't it? So that also tells you intrinsically that just from irradiance is not working. It's actually, you have to couple with how the energy got balanced and adjust itself, that it memorizes the system. That's where the memory of the thing that's able to smooth two hump into one hump, right? The camels, there's different kind of camels. So we have to study this topic carefully. That's where all my energies are into this. That's where all my energies are into this. Of late, there's one Dutch physicist who's a very old man and is trying to lure me into studying the diurnal changes, the day and night. And he doesn't realize that the mixed layer, what we call the area where they consider everything by motion, is very turbulent in the sense where the energy mixing is very well mixed. So between from surface to maybe 20-30 meter down, it's very well mixed. Between you measure the temperature here, measure here, it's the same because well mixed, right? But we show, in observation, real world, you can show that this mixed layer are changing by almost 3 meters over day and night. Don't you think you should study that carefully before you claim that you have that in your model? Actually, they got none of that in the model, obviously. So it's a problem. Another one of those problems. But think about people who want to study cloud. Does cloud measure in 100 years? No, it measures in minutes. This is one of the problems that the great physicist, meteorologist by the name of Professor Richard Lindzen often say, that these are all very fast phenomenon. We haven't even found the right measurement to try to describe it from an empirical point of view. And no wonder that one should remain always skeptical on any proposed mechanism, including some of mine. But I'm just saying that some of them is a lot more wrong than what I'm trying to say. So you have to weigh the balance. What are you trying to get at? Showing that you understand something or showing that you really actually don't understand the crap? This is a deep, deep problem that is very difficult. But to try to suggest the whole system is governed by this single atmospheric carbon dioxide is truly wrong. This is why it's not a serious question. It's not a very serious thing. No matter how much they want to insist, no matter how much they want to politicize, no matter how much they want to sell this fake notion that we are all corrupted by just money and wanted to do that. There are normal people who just want to live normal life, who want to just understand something. It has nothing to do with politics. It's about facts, about understanding. It's not about trying to destroy planet. Who wants to destroy a planet? I didn't wake up every morning want to punch climate in the face and want to kick this guy in the butt to do that. For what? It's actually trying to understand what is happening. And we actually learn a lot in the process, don't we think? We're able to study the thermometer data carefully and show that most of the warming that they show from 70s to 80s onward, and it's all contaminated by urban heat island effect, for example, in many of the thermometer data. We show that they are contaminated by land use changes. You know, imagine you put a station there, over time it become a farmland, later you put concrete over, then you change over time. That clearly is not measuring climate, is it? It's changing what you've done to your surfaces, right? Houston, flooding, what's the problem? It's really had nothing to do with global warming. It has to do with how the land surfaces has been changed over time and no drainage of the water. Those things have nothing to do with the intensity of the hurricane either, right? It just happened to a meteorological phenomenon that caused the hurricane to park there a bit longer. By the way, that phenomenon is called median-Julian oscillation. It's another one of those problems that I think people who's not keen observer of the climate tends to try to manipulate how people believe, and they try to create level of plausibility. Professor Michael Mann didn't show very carefully about the Gulf Coast sea surface temperature. It's been shown by Professor Roy Spencer, for example, that this thing have not really been warming according to what they think is warming. It's not. They are just telling the people that, oh, it's warming, but show me the facts. They did not show the data. You go look up Roy Spencer, no wonder people read his book because he showed the data. That kind of argument. You either want to wave your hand all day long and trying to essentially tell not untruth. I mean, what are you supposed to do? Probably we should call it telling lies, but what can I say? It's all about this sort of misunderstanding that somehow cause all the problem to be intractable. Climate itself nature is complex enough, and please don't introduce all this crazy notion about what we know and all these answers that is just built up from some kind of a strange belief that have nothing to do with science.